Okay, maybe let's get started. Cool. Well, good morning, everyone. Feeling good? Yes? Everyone awake? All right, cool. So my name is Evis Dernova. I'm the co-founder of a company called Neosync. We're a YC company, started in summer 22, been around for about 2.5 years. We're an open source data anonymization company, and we do a lot of work with synthetic data and just data anonymization, data in general. And so I was thinking for this kind of workshop, we would actually build kind of a basic version of what we do at Neosync using all open source tools, something that you can take back to your companies or to your side projects, and that you can actually extend and hopefully use, and hopefully they're useful. So that's the name of this talk, building a synthetic data generation tool from scratch, and we'll do it with all open source tools, stuff that you can just download directly from the internet. So as I mentioned, my name's Evis. I've been building products in data privacy for about the last 7 years. I was actually one of the first PMs at Skyflow, which is another company here at the conference, where we built the data privacy vault. Before that, I was a head of product at a company called True Data, based out of Chicago. We were doing a lot with mobile data for advertising. So data privacy at the time was a really important thing for us. We were dealing with GDPR, dealing with very sensitive data. So spent a lot of time thinking about data privacy from that angle and how we can protect the data that we have, both internally, but also just for our customers' data. And then previously, I was an engineer at IBM and Oracle and some other companies. And then particularly, I'm interested in topics at the intersection of AI and data privacy. There's a lot going on, obviously, with Gen AI and just AI in general. And so I think a lot about how do we protect consumers' data within AI use cases. Cool. So I'm going to go through just a couple of slides real quick, just to kind of like set the stage for everybody. It's not going to be that bad. And then we'll spend most of the time actually hopefully coding. Hopefully everybody's ready to do some coding. And then building this synthetic data generator tool. And we'll actually build 2 different versions of them. If we have time, I hope we do. We'll try to be quick. But I think it's going to be pretty cool. So we'll start with a more kind of imperative version, more rules-based, and then we'll actually do some machine learning at the very end. So the agenda is, what is synthetic data? Let's talk about that just to make sure everybody's on the same page. We'll talk about how it's used in the real world. So I'll give some real world examples of what we see with our customers, but then just more broadly in the industry. Then we'll spend most of the time actually building this synthetic data generator. We'll talk about expanding on what we built. So now that we have this little tool, how do we actually use that in a production type of environment, or how do we make it really useful for kind of more complex use cases that we see in the industry? And then we'll do just a little bit of wrap up at the end. Cool. So I guess before we go into this, show of hands, who has heard of synthetic data, knows what it is, maybe has worked with it in some way, shape, or form? Anybody familiar? OK, cool. So we got some folks who are familiar, some folks who are less familiar, so maybe this is going to be useful. So the way I think of synthetic data, and there's a couple different kind of definitions of it, but the way I think of it is it's data that's machine generated and meant to, quote unquote, look like other data. And we can kind of qualify the look part of it in 2 different ways. One is structurally, so it maintains the same shape as the source data. So the schema is the same, referential integrity is the same, our references don't get broken. It looks like that data from just a data format perspective. And then statistically is the other part of it. And statistically means it maintains the same statistical characteristics of the source data. So the same distribution, whatever kind of statistical characteristics you want to describe it. Ideally, you have the same distribution as the original data set in this new data set that you're building. And for some use cases, that's really helpful. In other use cases, it's actually not as important, and we'll talk about that. So kind of going into structural identity just a little bit deeper. So synthetic data should maintain the same shape and structure as the source data. So I think of this as schema, columns, primary keys, foreign keys, circular dependencies, unique constraints. You can imagine in the most simple of use cases, you have 3 tables, a users, accounts, and transactions table. If you're generating data that looks like that sensitive data in your production environment, you should effectively be able to pull up your sensitive data, drop in the synthetic data, and everything should just work. It shouldn't have any problems. Your database shouldn't be yelling at you saying you're breaking constraints or something is null. It should just actually work. And if it does, then generally your data is structurally in pretty good shape. Statistically similar. So like I mentioned, in some use cases, it's important to have synthetic data that actually has the same statistical characteristics. So a lot of these use cases are around third-party data sharing. If you're sharing any sort of health data, researchers really love They really want the data to make sure for it to be statistically similar. And there's some metrics that we use to track similarity. So KS test, total variation distance test, autocorrelation functions, correlation plots. And you can see one on the right-hand side. Essentially, like you can imagine a model or a distribution of data, and you're making sure that the features in that model or the data in that data actually matches the training data set distribution. And this is one way to do that. So how is synthetic data used? So I have a couple different examples here, and I'll kind of talk through these. So financial services, J.P. Morgan uses synthetic data to train fraud detection models. Because what ends up happening is in order to train a really good model, you need a lot of data. And for a lot of companies, they sometimes just don't have enough data. And so they augment what they already have with synthetic data that matches that distribution. So they have a really nice training data set that they can use to then train those fraud detection models. The other side of that as well is maybe you want to train or you want to bias your model for a particular use case, but you don't actually see enough of that, or maybe you don't see any of it. You can generate synthetic data that matches that distribution so that your model then is a little more encompassing of these kind of like edge cases that you'd want to test for. Fintech, so Stripe uses synthetic data for test sandboxes. If you've ever used a Stripe account, they have this like test sandbox feature. You can test payments and stuff. They use synthetic data to be able to seed that test sandbox with data that actually works, but isn't sensitive. And so you don't have to worry about the security and the privacy of it. Insurance, improving actuarial models through synthetic data training. Similar to the financial services kind of use case here, you want to get really good data so that your actuarial models, underwriting models are as representative, as accurate as possible. So we see this as well. Healthcare, health analytics, third-party data sharing without exposing sensitive data. COVID analytics was actually a project that I'd worked on in the past where states were sharing COVID data or COVID people got COVID across different state departments, and they didn't want to expose who those people were because at the time it was still pretty sensitive. So how did they generate data that looks just like the people who have COVID, and they can share that and they can do their sort of like analysis on it without actually sharing that person's data. Engineering, so better debugging and testing without exposing PII. This is one of the main use cases we see at Neosync. There are a lot of companies who have sensitive data in a production environment. They don't want to bring that down to staging or development, so instead they create synthetic data or use data anonymization to take that prod data, bring it down to staging or dev, give the developers really high quality representative data, and then they can kind of do whatever they want with it. They can recreate it, they can drop it, they can whatever they want. You don't have to go through like the data access process that you would with prod data if it was sensitive. And then lastly, what's top of mind for folks these days are LLMs, so create training data to improve accuracy, recall, so on. If you ever see any of the model release kind of press releases, they always talk about synthetic data. It's because it's really useful to just improve that training data set. And it's also useful for pre-training and post-training as well. So I think the punchline here is like, it's actually used everywhere, even if you're not realizing it. It's pretty useful. A lot of teams are using it in a lot of different ways, a lot of different sort of industries. It's just in some ways not talked about as much as I thought it would be. So who uses it? I think of it breaking down into two different kind of use cases, and you can kind of take those use cases from the last slide and kind of bucket them into two. One is developers use synthetic data for testing, debugging. Performance testing is another use case we see a lot of. I have a data set, maybe it's 1 million records, but I really want to like hammer my services in my database with a lot of data to test benchmarking, performance testing, load testing. So can I use synthetic data to create 100 million records from those 1 million records and then do that? And then anonymization and just general development, so having a really good local developer experience. And then on the other side are more of the machine learning and AI engineers, so generating data sets for analytics, fine-tuning, privacy-preserving analytics, expanding training data sets, training LLMs. Cool, so how is synthetic data created? So this gets a little closer to what we're going to be doing. So the first way is using machine learning models. This is pretty popular, so you have GANs, GNNs, general neural networks, VAEs, variational autoencoders, convolutional neural nets. There's a whole bunch of different models you can use, and some are very specific to generate very specific kinds of training data or synthetic data. Some are very good at generating time series data. Others are better at generating more relational data. And there's some pros and cons to these. So like machine learning models are great at maintaining the statistical properties because they can learn on that initial training set distribution. But they're not great at maintaining structural properties. It's actually really hard to tell a model that, hey, this is like a foreign key reference, and so if you're generating synthetic data, A has to be the same as B in table A and table B because that's what my foreign key demands. And they're still struggling with that a little bit. And they're a little bit slower, and you have a little bit less control over what those models generate. And so what we see is whenever we're working with machine learning models, we tend to do a lot of training runs. We're always messing with like hyperparameters and trying to like get to what we think is a reasonable outcome or product of these models. The second way is, in some ways, I think a little bit less talked about, but I think it's just as important and it's just as useful, are more of like rules-based systems. Maybe not as sexy as machine learning models, but you could think of using something like a pseudo random number generator to iterate through a list and imperatively create synthetic data. So imagine having a list of 100,000 first names, last names, addresses, and you're kind of mixing and matching these to come up with synthetic data that isn't through a machine learning model. And so this is great for maintaining structural properties because you can very clearly say, hey, if I have a table here, I want to generate data that matches the schema. Now, if I want to go insert data into another table that has a foreign key reference, well, I can just look up what I inserted into column A that has a foreign key reference and then insert that into column B in table B. And that's really hard to do, as I mentioned, with machine learning models. So you should have a lot kind of like lower level control over the data that you're generating. And it's also a lot faster. Computers are really good at generating random numbers and iterating through lists and going through different data structures. But it's not very good at maintaining statistical properties. And so if that's something that you need, machine learning models are definitely the right way to go. If you're like, I just need some data that looks like production, I need to be generated fast, and I want to be able to like really like granularly control it, a rules-based system may work. Cool. I told you guys it wasn't going to be too bad with slides. It's just a couple just to set the stage. So let's get ready to hopefully build something. And I guess show of hands, like who's going to be actually coding versus kind of just watching?
We can code along with you on this?
I would love it.
Okay, yeah. Depends how intense the coding is.
Well, I guess another show of hands. Who here has ever written Go before? All right, you got a couple. Python? Okay, cool, sweet. So I published a Git repo that I'm going to go through, so you can actually pull that down locally if you'd like. And you can code along with me, or I can run through the repo and I can show you how these things are built. We can go through it step by step and go from there. All right, so what are we building? So what we want to build is a synthetic data pipeline that'll generate 100,000 rows, or sorry, 10,000 rows, could be 100,000, of synthetic data for a users table with these columns. So ID, first name, last name, account number, routing number, and card number. So we're at a fintech conference. We need fintech data, financial services data, card number data. All this stuff is pretty sensitive, right? Like you generally wouldn't want to kind of pass around card numbers, account numbers, especially if you're in a PCI compliance environment. And even first name and last name, we consider that as PII. And then for our tech stack, we're going to be using Go. So that's going to be a lot of fun, I think. We're going to use this product called Bento. It's an open source product for data processing and streaming. I'll kind of talk a little bit more about Bento. And then we're going to use Postgres, which is everybody's favorite database. If you're going to follow along, what you need, a laptop plus internet connection, Docker, if you're into that sort of thing, and then patience, and of course, burning desire to learn. And this is our master plan. So the way to do this is that we'd want to get a local environment set up. We'd want to download Go if you don't already have it, download Bento, pretty easy to download. We want to create a basic config, and I'll talk about what a config looks like, and I'll actually pull up Bento and show you what that looks like. We'll want to sanity check that everything is set up correctly. We want to define our synthetic data generators, generate our actual data, and then set up Postgres, and then sync the data to our Postgres database. And so in this case, we're going to be actually generating data from scratch, totally, and then seeding a Postgres table with 10,000 rows of data. And hopefully that kind of gets the imagination going of what you could do if you decided to extend this further. So I'm going to pull up Bento just to show what Bento is. Maybe some folks have heard of it. So there's a project called Benthos. It's a data streaming process. It's declarative. It really focuses on reliability, and so it guarantees delivery. It just continues to try if the endpoint isn't available. So that project actually got acquired by this company called Red Panda. They're another data streaming company. And then before it got acquired, they essentially forked it into Bento. And we use Bento all the time at Neosync. It's super, super useful. If you're doing any sort of like data streaming work, I would highly recommend it. It's great. We love it because it's declarative. It's really easy to work with. Covers a whole bunch of inputs. So let me go to components. So these are all the inputs you can put into Bento, and it'll stream that data across. You can batch that data accordingly. All the AWS products, pretty much every database you could think of. Also more generic, like SQL query selectors, and then same thing on the output. So if you're doing any sort of like data processing ETL work, check it out. It's open source, and it's really useful. Cool. Are we ready? All right. So first things first, let's get our local environment set up. So I already have the repo pulled down, but if you want to pull it down, you can go to github.com/Evis Drenova/syn-data. So here you can just git clone this down to your local environment. This is going to have like the, oh yeah. Hold on. All right. Cool. No problem. Can everybody see that okay?
Yes.
All right, awesome. So this is like the final repo of what we're going to be working with. It's all there. But I think it'd be pretty interesting to actually like build up to this because it's cool when you kind of go through it step by step and you can see how you can kind of like continue to add on new columns, new data elements, and then we'll eventually get to something that's hopefully workable. If the demo gods are shining on us today. All right. Cool. So for our local environment, I mean, first thing we want to do is create a project, right? So I think we'll just want to like make dir, give it some name. I called it syn-data. You can give it anything else. And then you'll want to cd into that. So let's just go ahead and do that.
If we clone your repo, should we still do that?
You don't have to, necessarily. It's going to be a lot shorter of a presentation if we want to go that route. Because it's already done.
Oh, okay. Yeah, we're kind of retracing your stuff.
Exactly.
Okay, that makes sense.
Yep. I mean, we could just comment stuff out. That works, too.
No. I don't want to derail this at all.
No, it's all good. So I'll go through it, and then you can kind of follow along. OK, cool. So I have this directory here that I pull my projects in. So I'm just going to like make dir. I'm going to call it syn-data2. cd into that. And then I'm just going to open that up in VS Code. OK. So directory, have a project opened up in whatever editor that you like to use. And then we can actually just download Bento directly using this link. So if you go to the Bento website, you can see that in the guides. There's a getting started guide here. So if you're using Mac, or if you're using Windows, or if you're using Linux, you can also just do it via Docker pull, but I'm just going to do it just with a bash script here, a bash command. So if you throw that into your terminal in your project, you should see this Bento installer. It's going to downloading Bento for Darwin ARM64, because that's my machine. And then after 20 seconds or so, it should all get downloaded.
So we just run that curl command in our folder we made?
Yep.
Okay.
I guess based on the Wi-Fi, it might be a little bit slower than you'd like. Cool. And then I'll put that into your user local bin folder. And then if it works, you should see it successfully installed like that.
Do you mind making the text really big?
Yeah.
So I can see the original command?
Yeah, for sure. So.
And I'm going to just sit closer to that.
Cool. Also, or you can go to this website right here. And that'll have the command as well. Oops.
Sorry for all the questions, but is it like a pipe character before the bash? Or is it like an L?
Which one? Here? This is a pipe.
Okay, thank
Yeah.
you.
And wait, give me 1 second. I think that got copied over from the last one. There we go. That's what we want.
Okay, perfect. Just,
Cool. Show of hands. Anybody done? Ready to move on to the next step? Got 1, 2. Still downloading. Okay. And if you need the Wi-Fi, let me know. I have it up here. I can say it out loud. Instructions are to not share with attendees, but that's okay. Maybe I won't get invited to speak next year. I don't know. Who knows?
mine is done.
Cool. So 3. Anybody else still waiting? Good to go? All right. Cool. So part 2. Hopefully we don't get too tripped up here. So if you don't already have Go, we want to download Go to our local machines. So there's a couple different ways you can do it depending on the type of machine that you have. So you can either use brew. So if you're on a Mac, you can do something like brew install Go. You could download it from source if you're into that sort of thing. If you're using Windows, you can also just use the Windows installer with the .msi to open it. And so if you go to the Go website, so you can I'll actually just put it up here. So if you go to this website, go.dev/doc/install, you'll get taken here, and then you can download it for Linux, for Mac, or for Windows, whatever you're using. And so I use a Mac, so I just did brew install Go. It's pretty easy for me. They take care of like putting the right, like getting your path set up and everything. I think the Windows MSI installer should do the same thing. And then I think for Linux, you can download it that way too. Take a minute here for it all to work. What does everybody code in? Just curious if you're doing day-to-day like development work. JavaScript? TypeScript? Java? Should all move to Go. And then just to verify, as we're getting there, you can just type in Go version. It should see something like this. I think the latest is 1226, maybe. I'm on 1222. Yeah, 1226 is the latest. Anybody have success yet?
It's just taking a long time to install. It's stuck at a certain percentage. Hasn't
Yeah.
changed. Oh wait.
It'll take a minute.
Never mind. It's done. Just
Good.
have to scroll down.
Ah.
Terminal. That's weird that the percentage didn't. Oh, you know what? No, I know why it's done without complete percentage. It fails for some reason. I'll look into that.
Question, when you are generating this synthetic data, how long does it typically take on, in production you have a lot of data, right?
Yeah.
So
Yeah. It depends, and there's different, like it all depends on how much data you want to generate, the format and the structure of that data. But there's a lot of ways to optimize this. So one thing that Bento is really good at is parallelizing things. And so you can parallelize this as long as you have workers, and so you can throw, in some ways, more compute at it to go a little faster. What we see at Neosync on average is like we can generate 1 million records in like 90 seconds. And so if you want to generate 10 million, it's probably going to take, I think it's linear from our testing. So it'll probably take 900 seconds, which is still in the order of like minutes usually. If you want to go more than that, it'll take a little longer. So depending on how often you need it, most of our customers tend to just do it overnight. So they'll like set it to run at 2 in the morning. It'll be done by 3 if you want to generate a lot of data.
Mine's installed now.
Cool.
So this is fetching from like a production database, anonymizing it and sending it.
If you're doing it that way, yeah. What we'll be doing today, and what we support as well, is actually just generating it totally from scratch. Like it doesn't take an input in. But if you want to take an input in, you can do that as well. That takes just a little bit longer. Like I think what we see is for 1 million records, it's like just a little over 2 minutes. So it's about 30 seconds longer. Cool. Anybody still waiting for Go to download? You sure? Okay. All right. So we got the not as fun setup out of the way. So let's go back into here. So on the right-hand side, so we have this Bento config. And so like I mentioned, Bento is declarative. So it essentially is structured into 3 different sections. We have an input. We have a pipeline, which has an array of processors. And then we have an output. And so the most basic version that you could create is input. It takes in some input from standard in, has a pipeline with no processors, meaning you're not changing the data, you're not transforming it in any way. And then it has an output. And it just writes directly to standard out. And so we can create this just by running this command here. So bento create, and then this caret thingy, config.yaml. Now I'll blow this up a little bit just so we can see it. So you can just run that directly into your terminal. And then what should get created, and I'll just run it here, you should see this config.yaml file. And then it's going to create this really big config that we don't need. We definitely don't need all of it. And so what you can do is you can delete everything before input, which should be on line 18, and just keep it input standard in, delete the buffer, and then delete everything after output standard out. And then even the threads. And so you should get to something like this. Did that work for anybody? Yep. Other folks? You can run this without Go working, by the way. The Go part will come in a little bit later. I just want to do it first because sometimes we can get a little tripped up on it. Anybody else waiting on this step? Good to go? OK. Cool. So let's do a sanity check. So we have something here. So we have a config that we can run. And the way that we run this is we'll run this command here, which I'll talk about in just a second. And everything that you type into the terminal should get printed back out to standard out. And so you can run your config using this bento-c config.yaml command. I'll blow this up a little bit. I'll show what that looks like. So if you go back into your terminal and then you type this in, you should see these couple log lines. Now if I type in hello, I should get hello right back. Hello, bento. Hello, oh, hell bento, no. Hello, bento. Hello, bento. And what's happening here is that everything that you're typing into the standard in, so you can see the first kind of like line of this file here says input standard in, will get printed out to that input standard out. And then what we're going to do is in the pipeline, in the processor section, we're going to start to manipulate this data. Yep. Did that work for anybody? Is anybody able to get to that? One? Anybody else have success? 2, 3. Cool. Sam? Nice. OK. Let's make one small change, and let's see what happens. So I'm going to go ahead and copy this, and we'll walk through this. So let's go ahead and delete the array here in the processor section. And then let's create this mapping. And so this is in the processors. You want to go down. And this is YAML, so white spaces do matter. And I'm sure I'm going to probably mess this up a couple times. But you want to do this dash mapping, so add in this field here, or this value. And then have an ellipses, and then root equals content, parentheses, so it's a function, dot uppercase, and that's our method. And then we can go ahead and save that. I'll leave this up for here for a second. Now when you run this, so if we run our config again, so that bento-c./config.yaml command, and it works and everything looks good, everything you type in should get uppercased. So if I go again, hello, I should see hello now in all caps. Because as that data comes in through standard in, it's going through this pipeline processes and it's being mapped. And so what the mapping says is anything that gets mapped to the root document, which is then on the content sort of function here, we're just going to uppercase that. Was anybody able to get this working? Cool. Take another second here, and then we'll move on to actually doing something interesting. OK, sweet. So let's move on. So I think our sanity check is pretty good. We're relatively sane. Things are working as we expect them. You can imagine how we can continue to add on more mappings to be able to manipulate the data in different ways. And then you could also think about, well, our standard in or standard out really can be anything, right? Like Bento, like I showed in Bento. It could be a database. It could be a flat file. It could be a Kafka stream. It could be kind of anything. That's the power of Bento. So let's do something more interesting. So we want to work up to populating a table with 10,000 rows of synthetic data. So let's start taking a step in that direction. So our schema is an ID, which is of type UUID. Our first name is a text, last name is text, account number is a number, routing number is a number, or an integer, depending on your type system. And then our card number is a number, as I mentioned. So I think the first place to start is let's just start generating some UUIDs for our ID, because nobody's using sequential primary keys, right? So how can we generate some IDs? So luckily, this is pretty straightforward. It's just a little bit of what we've already been doing. So there's two changes we need to make. We need to update our input to use one of Bento's built-in kind of input generators. They call it generate. You can pass in a count, and then you pass in a mapping. And that mapping defines that root document. So let's go ahead and do this now. So I'm actually just going to copy this over, and I'll put this up on the big screen here. Let's see. Hopefully YAML doesn't yell at me. So in our input, we're going to go down and put in generate. We're going to put in this count of just 10, because we just want to generate 10 records. And then in our mapping, we're going to create this root equals object ID in quotes, and that's going to have a value of just an empty string. And so we're defining what that input structure looks like. And then in our pipeline, it's going to say processors, have it create another mapping here, and that's going to be root.id, because we're dot notating into that ID field. And then we're going to set it equal to the UUID underscore v4 function. And what's nice about Bento is it actually comes pre-built with a lot of these functions that you need to generate some data. And so we're going to take advantage of that as well as create our own as well. And you know what I'm going to do just in the meantime? I'm actually going to put up this deck into the repo. I probably should have done that before, just so you all have it, so you don't have to so you can just get this stuff a little bit easier. Oh, this is not going to like that. OK, fine. Okay, so if we all have that done, then what should happen is if we save this and then run our bento config, we should start seeing these ID lines or objects get generated here. And there should be 10 of them because we specified 10 as the generate count. So you should see something like this. I'll show the command up here.
What command did you use to?
Just run the config, so the bento-c and then /config.yaml. So that's the command we'll use every time to run it. Pretty much every time until the very end. We'll change it a little bit. Was anybody able to get that working? Sweet. Working for you?
Oh,
Can you enable the permissions on Google sites?
Oh, yeah. Should be on the viewer. Maybe try it again.
You need to change the org for Neosync to disable.
How do you make it for anybody?
If you copy link,
Yeah, that's one that I copied, but I wonder is there a way to make it?
it's only inside the org.
Yeah.
Once you got it.
Let's see. Share. Oh, restricted. That's not intuitive. Sure. Try that.
G Suite admin might have rules set up or something. I don't know.
So it says click the share button in the top right corner, click the down arrow next to restricted, select anyone with the link. Okay.
Did the link change? It's a little weird, but
Yeah, I don't know. Oh, there we go. So you have to go to restricted first, and then you can go to anyone with the link. Is that working now? Okay. That does not make sense. Cool. Was anybody else able to get the ID working? Move in the right direction? Yes? Sir, you here? What's your name?
yeah. Sunwoo.
Was it?
Sunwoo.
Sunwoo?
Yeah.
Okay. Sunwoo, you good?
Yeah.
Awesome. So we have some IDs. That's cool. We can insert this into a UID column into a Postgres database, and it shouldn't yell at us. Like, that should just work, which is pretty sweet. And all we have to do is actually just assign a function to that root. So let's expand this a little bit. Let's start generating some first names. So we can actually do something really similar to what we just did. So let's go ahead first and update our mapping. So here, what we're going to want to do is actually just add in another key called first name in quotes to our mapping, and then set that also to an empty string. And so that's on the input under the generate field here. And then we'll do the same thing here on the root, and I'll show this in a second. One minor change. Cool. So you can use this pipe character here just to denote multiple lines. So let's just create another root.firstname, and we're going to use the fake. So this uses the faker library that Bento comes pre-built with out of the box. So you can pass in fake function, and then as an argument, you can just type in the first underscore name param here, and then put that in quotes. And if that's all working correctly, we can run our config again, and we should start seeing a first name key here in our object with some what looks like first names. And it should generate 10 of those again.
This functions like
Yeah, it's a pre-built function. But we'll also write our own, hopefully. Was anybody able to get this working? Awesome.
Where do you find those slides, by the way?
So I just put it directly into the GitHub repo.
No, I mean the Google slides. The slides.
These ones?
Yeah.
Yeah, I just put the link in the repo. So if you go to,
Oh, I
yeah.
see, you did.
So if you go to Evis Dernova, GitHub Evis Dernova /sin data, it should be down at the very bottom.
Right.
I just have a silly syntax error, but I can't seem to figure out what. In my YAML file,
Yeah, it's probably a white space problem. It's usually what I see.
that mapping is, how indented is it?
I think it should be 2 tabs
Okay, that might be my issue.
or 4 spaces.
Yeah, it worked. Okay.
Sweet.
I think, oh yeah, there it is.
Cool. So let's keep going. Let's start doing the same thing with last names. Luckily, last names is the exact same thing, and it's super easy. So we can just go ahead and create another key here in our object, in our mapping, called last name or last underscore name. And then just create another root mapping. So root dot last underscore name equals fake last name.
Seems like it returns the mapping elements in alphabetical order for me. Let me see if it's doing that for you. Yeah, or maybe it's a coincidence.
Could be a coincidence. It shouldn't return in alphabetical order. At least we haven't specified it so. And so if you're able to get the last name going, now we should see something like this, where first name, ID, oh, you're seeing the actual keys are in alphabetical order of the object.
Yeah.
Oh, okay, yeah. So now we have what seems like an actual user record, right? We have an ID, we have a first name, we have a last name. Oh no. The dreaded Google Calendar notification. Hopefully I don't get a Slack notification and set anybody off. Just like get triggered by it like I do.
I feel you. No, yeah. Oftentimes I get bad news. So.
Cool. Was anybody able to get the last name working? All right. We're full steam ahead. So let's move on. Okay, now we get into some numbers. So let's talk about generating some account numbers. So account numbers in the US, they vary by structure, usually anywhere between like 9 to 12 digits. Countries use IBAN or SWIFT, which are obviously more standardized. The US doesn't really have that, depending on the bank. I mean, I guess it supports it, but most of the US banks tend to kind of do something a little bit different. So what we're going to want to do is generate an account number that's between 9 and 12 digits long. Now, if you think about it, account number is really just an integer, right? It's not a float. There's no decimals. It's really just a string of integers, I'll call it. But it's really just a long integer. So let's do just a tiny bit of setup to get this right. So here's where we start writing our own custom functions. Now, Bento does have their own pre-built, like what they call random int function. And we could use that, but that's not that exciting. So let's just create our own. So let's set up Go for a minute here. So if your Go setup worked correctly earlier, let's go ahead and create a Go module. So Go modules are just ways of, think of it as like packages in other languages. So you can run that by doing go mod init main. And that main is just the name of that module. So it's kind of almost like a namespace, you could think of it as well. So I'll run that on my end just to show what that looks like. I'm just going to make this a little bit smaller. Cool. And what should happen when you run it is you should see a go.mod file that gets created in your directory. And it should just say module main and then the Go version that you have locally. So mine is Go 122.2. Did that work for anybody? Couple? Yes?
Same thing for Python?
You have to use Go, unfortunately, for Bento. Because it's written in Go and they support Go. We'll do a little Python work, though, a little bit later. Okay, cool. So once you've created that module, let's go ahead and just pull down some dependencies or some packages. And so I'd probably recommend just pulling down the slides for this instead of reading through it. And so what you can do is you can start pulling in go get. This might get a little finicky, but let's give it a shot. Or actually, sorry, one step before that. Let's create a main file. Let's do that first. So in our project, let's create a file called main.go. So I'm just going to do like touch main.go. That should just create an empty file, right? And then we'll want to declare a package, which is our main package that we've already declared. And then we'll want to just create a main function. So func main. And I'll talk about what this service.run CLI is here in a second. I'm just going to comment this out for now. So you should create a Go file, and it should generally look like that.
Are 2 slashes like a comment?
Yeah.
Okay.
Yeah, I'm just commenting this out for right now. Cool. Was anybody able to get this working? Have a Go file? All right. So then let's just go back to that last step, and then let's start downloading some dependencies. And so you can use go get. That's like an npm install. And we're going to do just this service one first. So go get, and it's github.com/warpstreamlabs/bento/public/service. And when you do that, you should see a bunch of Go packages added, as well as a go.sum file in your repo here. That's basically like a package.json file. Okay, cool. And then we just added just a couple of things here. So we've created this import. So in Go, you can define your dependencies using import. So create import and then open parentheses. And then you want to take the dependency that you just downloaded, that you use go get, and then include it in quotes inside of that import. And then you can also add in the context here as well. And so your import statement should have just 2 lines here. You can separate them by an empty a break if you want. And then in the main function, you want to just put in service.runCLI, and then inside of the runCLI context.background. And so what we're doing here is we're just setting up Benthos to be able to run programmatically. And so here it's actually going to be triggered from a Go file as opposed to running through the command line. So service.runCLI is just their way of doing that. And if you have the repo, one way to do this as well is you can see the dependencies that are in that repo in that main file. And you can actually just go get all of those and then just include that inside that import. But we'll get to that as well. Was anybody able to get to this point? Cool. Couple. Are you having issues, sir, up here in the front?
I'm downloading Go now.
Okay. You didn't do it when I told you to do it. No, I'm just kidding.
Python is completely on the
Yeah. You'll be our Python guru once we get to it. You can help everybody with virtual environments. Okay, cool. We're going to move forward just in the interest of time. So there are some other modules that we want to include here. So I'm just going to go get these. If you have the slides, I'd recommend just pulling these down. We'll use them over time. Oops. Yeah. The other thing you can do that's kind of nice about Go is you can actually just, if you have the repo, you can copy everything down and then just run go get, and it'll actually just do them all for you. So you don't have to do them one at a time. Or you could just do them one at a time like I am. Cool. And then in Go, we do this like underscore thing in front of the dependency if you don't want it to be named. So you could do like you have in like JavaScript or TypeScript, you could do like import blank as blank. In Go, you can do the same thing. You can name that dependency, or you can just do an underscore just to like notate that it's just not going to be named, and you're just like it's an unnamed import. So you should have 4 things here. And we'll just use these kind of down the line, but just to get it done first. So you should have a /service, /components, /IO, /pure, /extended, and then /components, /SQL. And that'll get you all set up for everything else. Okay, cool. Moving on. So one thing that we're going to want to do is, if you think about what we're creating an account number, which is really just a bunch of integers. We're also creating a routing number and a card number. Those are also all just integers. And so one thing that we can do is we can actually just create like this util function that's going to power all of these different generations. And that we can just reuse that. And then all of our kind of specific card number functions, account number functions are all just really just wrappers around this small util function. And if you have the repo locally, you can see this, or if you're going to GitHub, you can kind of copy that over, and I'll kind of talk through what that util function looks like. So I actually just created this in my main file. And this will generate a random integer and returns it as a string, given some length. Because we know that card numbers or account numbers can be between 9 and 12 letters, or integers, characters, we want to be able to pass in this length parameter. So we can say, hey, we want a number that's 7 characters long, 10 characters long. Card numbers are 16 characters long, typically. And so let's kind of just walk through what this does here. So the first thing it does is that it checks if the length is less than or equal to 0. So it obviously must be a positive integer, I guess. And if not, it'll just return 0. And then it does a little bit of just kind of like math stuff in here. It says to create a minimum, we'll cast in it 64. We'll use the math package. And we'll take a power of 10. And essentially what this is doing is it's taking the length, so let's think of that as the number 9. It's subtracting it by 1, so you get to 8, and then it's multiplying it by a power of 10. And what that's setting is that's setting a lower bound into what this integer that we could generate is going to be. So if, for example, let's say you have the length of 3, that's going to return back a 1 with 2 zeros. And so that's going to say, for length of 3, the minimum it can be is 100. And then you can imagine the maximum is going to be 999. And that's what this max does too. So a little bit of Go code just to essentially set some bounds on the number that we could generate. And then from there, we want to be able to create this random number, right? So we want to set a random number variable. Go has a nice package called rand, which just generates pseudo-random numbers for you directly. Has this method called int63n, and then we pass in our max minus min plus 1, and then we add on to the min. And that creates this bounded range between our min and our max, and it asks Go to select me a number between this min and this max. And then lastly, we format the integer to return it as a string, and so Go has this nice package called string conversion, or strconv, and then we pass it the number that we want to convert, and then we just pass in a base as well. And this is pretty much going to be the basis for all the numbers that we want to generate, because we're essentially saying we've created this util function that can take in a length and then return back a number that is of that length, but it's random between the minimum of that potential length and the maximum. Cool, so let's actually see that in action. So let's go ahead and generate some account numbers. So I'm just going to go back into, make this a little bit smaller. I'm going to create a file called account numbers underscore, or yeah, account underscore numbers.go. I'm going to set my package to be the main package up top, because we have to do that for Go. And I'm just going to pull over the code here that's already completed so you can see it. So if you copy over the account underscore numbers file that's in the repo, it should look something like this. Now, one thing about Go is you can actually run a specific function called the init, and it actually runs it on program initialization. So it's almost like this kind of like it's a use effect in React in some ways. Like as soon as a program initializes, it's going to do this thing first, and then you could also have like a main function after this. So it's useful to be able to do some things right off the bat. And the way that Bento uses this is it uses it as a way to register functions with the config. And what it allows us to do is then use this generate account number in our config directly. And I'll kind of talk really quickly through what we're doing here. And so we're creating this spec. So bloblang is their language called bloblang that Bento uses. It's like their DSL effectively they've combined or created. So you can do bloblang.newPlugin spec. This creates a new spec for a function that you want to generate. And I think here's where like the power of Bento comes into play. Is now you can do anything that you want. You can generate whatever you want. Data, not like numbers, characters, pass in regular expressions. Like you can do anything here. And that's what is, I think, pretty interesting is now this opens up the world to us. We're not just confined to those pre-built Bento functions that we have. We can do whatever we want. And so we write this code here. So error equals bloblang.register function v2. And so this registers a function with Bento when the program initializes and makes it available to our config. Pass in a function name, so I'm going to call it generate account number. Then we pass in some other parameters that we're required to. And then inside this closure here, we just define our function. And so we're saying just return a function, return an any or an error, and then we actually call that function we created earlier, which allows us to generate all the numbers that we want. And we pass in a length. And so we're essentially saying, hey, I want to use this generate account number function in my Bento config, and I want that to underneath call generate integer with length, and I want to generate an integer of length 10. And if there's an error, panic and kind of yell at me a little bit. Cool. So let's keep going just in the interest of time here. So we can go ahead and update our config. So one thing that we'll want to do is go back to our config.yaml file. And let's just add on to our root object here. So this will be now account underscore number. And then instead of doing an empty string, we're going to do just an integer because we're creating an integer. And then our mapping, we're going to do root.account underscore number. And instead of doing fake, we're actually just going to call the function that we just created. So generate account number. So the last step as a part of this is now we actually have to build a binary. Because we're now calling Bento from our command line, and we're doing it kind of like imperatively, or from the scope file imperatively, we actually have to build just a small binary. So what we can do is we can run go build. Or you can name it as well. Let's do that. Cool. And so you can do -o and give it a name, like I just did CB for custom Bento. And then when that works, you should see this CB binary file that gets dropped into your repo here. And now when we run that, and the way you run that is you do /cb -c for config for Bento, and then pass in that config.yaml file. And that's going to start outputting some account numbers. So now you can see here in this account number field in our object, we're generating random account numbers of length 10. And it looks like an account number. I think it does at least. So you can imagine now, like, if you had some validation as part of this account number, like let's say all your account numbers started with 425 or whatever, you can just come in here into your account numbers file, and then you could just update that function to say, hey, for the first 3 numbers, it should always be 425, and then generate integer with length 6 if your account numbers are 9 digits long. So now everything's going to start with 425, and it's going to generate random account numbers for the remaining 6 characters. Was anybody able to get that working? I know I had to go a little faster at the end just to kind of push through a little bit. OK, cool. Let's do one more thing, and then I want to fast forward just a little bit in the interest of time. OK, we ran it. Great. Let's create some card numbers. So we know card numbers, the first 4 to 6 digits are bin numbers, and those have meaning, right? It's going to be Visa if it starts with a 4. It's going to be MasterCard if it starts with a 5-1. And so what we see a lot of this is customers saying like, hey, I actually want to validate the card number. I need it to be LUN valid because it has to have the right checksum. I want to do specific routing. Maybe I'm working with some front-end components. I want to show my little like Visa icon or MasterCard icon. And so I care about the number that we're generating. It can't be just totally random. I have to kind of put something together that makes a little more sense. And so we can do that with another function. And so what we can do is let's go ahead and create this. So touch card number.go. And then just like we did for the account number, we can do the same thing for the card number. So I'm just going to pull over what we have here. Cool. And this one is just a little bit longer of a function, but we'll walk through it. It's really similar. So the top section is the same. It's just func init, like we saw in the other one, generate underscore card underscore number. And then it calls this generate card number function. So in here in our return, we're returning this function that we're calling. And this actually calls this function directly here. So like I mentioned, right, you can call that, like in the account numbers example, we actually called the generate integer with length function directly in our main file. But you don't have to do that. You can actually have more logic embedded. And so here I just have a function that says Visas always start with 4111, MasterCards always start with 511. For example, I want to generate a integer with length 12. And then I want to randomly just select between Visa and MasterCard one of those numbers to start with. And what we do is we just say rand cc, select a number between 0 and 1. And then if the rand equals 1, return Visa. Otherwise, just return MasterCard. And then we're going to append those two together. So if we build this, and then update our config as well, so root.card number equals generate card number. Oops. Sweet. So now we can start to see here, we have this card number key value field right in our object. Everything either starts with 411 or 511, and then the remaining numbers are all random. And so now we get to like a pretty representative or like a pretty real looking kind of row of data for somebody, right? We have an ID, which is a UID. We have a first name, we have a last name, we have an account number for them, and then we also have now a card number for them. And so now if you're doing any sort of testing locally and you're not PCI compliant, right, and you don't want to have those card numbers, but you still need something that looks like a card number, you now have a way to generate as many card numbers as you want. You can generate hundreds, thousands, hundreds of thousands, millions even. So I'm going to fast forward just a little bit because I want to show what this looks like if you actually start doing some machine learning, because I think it's pretty cool and pretty interesting. So the part that I'm going to fast forward over is just how you insert this into a database, and I'm going to show you what that looks like. It's pretty much just configuring something in Bento. And so all of this is in that repo, including my database password, which I should probably change. That's OK. You essentially just configure this SQL insert. And so this is just a driver. It talks to a Postgres database. You pass in your destination or your DSN, which is just your connection string. You set a table name, you set some columns, then you do some mapping. So you can look at this and kind of mess with this on your own time. And then eventually what that gets to, and I'm just going to use Neon here just as an example, is something like this. So we have an ID column, we have a first name, last name, account number, routing number, and card number. And this should be so we have 10,000 here because we set that generate to 10,000 once we actually ran this for real. And so what you can actually do now, I'll kind of show this here. And so in this repo, I have this folder called PyDataGen. And so I mentioned in the beginning, like, what if you care about statistical consistency? Like, what if you want to make sure that your distribution of the synthetic data you generate matches the distribution of the original data set that you're working with? Well, we can use Python to do that. And so here in the code, I have this Python file I've written. And essentially what this does is this uses a model called the CT-GAN model. It's a conditional transformer general adversarial network model. And this learns the distribution of the original training data set and then generates new synthetic data that matches that distribution as well. And so in this file, I'll just walk through this quickly. We define a Postgres connection, which is Neon is a Postgres database. And this just uses SQL Alchemy to connect to it. It reads in all that data in that table into a data frame using pandas. And then it runs this generate synthetic data function here. And what this is doing is this is setting some hyperparameters. We have epochs runs set to 100, batch size 500, and the number of samples we want to generate of 1,000. And we drop the ID column. This is just a little bit of a nuance because ID is like a UUID, and PyLance doesn't like UUIDs. We set some categorical columns, and so this is required as part of the model to say what columns are categorical versus what are discrete. We then define our model here, and then we fit it. So we actually train that model, and then we sample from it, or we infer from it, to generate 1,000 rows of synthetic data. And I can show you what that looks like here. I mentioned something about virtual environments earlier, and they came back to bite me, you know? I knew it. They always do. All right. Oops. Okay, so I just created a virtual environment real fast, installed my dependencies, and now I'm running the file. And so it says data loaded successfully, starting to generate synthetic data. And so here's where it's actually training the model on that table that I generated using my bento config. So this pipeline is now like I've generated brand new data from scratch, I put it into a database, I've then trained a model on that data to then generate brand new data that looks just like it. So you can imagine that Postgres database is like your production database. And if you can run a model on that, you can actually generate brand new synthetic data that maintains those statistical distributions or statistical characteristics. And it usually takes a little bit to train and then to run. I'll fast forward a little bit. So essentially what it's going to do at the very end is actually just output to the synthetic_users.csv file. And this is what we'll get. We'll essentially get this CSV file of all synthetic data that we've generated based on that original training data set that was in that Postgres table. So we loaded that into a data frame, trained a model on it, generated brand new data that looks like it. And what's really great about this is that you can generate way more data than you already have. So you could say, I have 1,000 records, I want to generate 100,000 records. Cool, it can do that. You just pass in that num samples parameter. And so this is pretty cool because in some ways, you know, we started doing this originally with bento, and it was very imperative. Like we had to define this object and then like write this function to generate, you know, a first name and a last name. And that's powerful, right? That's a rules-based kind of approach where you have a lot of control over what you generate. But it doesn't do any of the statistical characteristics. It doesn't match any of that, and it's a little bit like it's, you know, you're in the weeds. And now if we do it with a model, it's a little bit different because now we don't have as much control over the data that we're generating, but it's also a lot more streamlined. Like all we did was train a model on some data, run that model, and that all of a sudden outputs a lot of records that look just like our original data, right? Like here we have a UID, we have a card number, we have a routing number, an account number, last name, and a first name. And so my goal is to show that you can generate synthetic data in two different ways. And depending on your use case and your requirements, you may have to do one or the other, sometimes even both. Like we do a little bit of both, and we see that as well, to get to that final data set that's actually really useful for you. And so I know we had to kind of rush through things, and we're at the end here a little bit, but the repo is up there. I would recommend checking it out. Kind of play with it on your own. Let me know if you have any questions. Feel free to like shoot me an email or something. Always happy to help. But I think generally synthetic data is it's pretty useful and it can be really powerful, especially from a security and a privacy perspective. And the last thing I was going to finish up with here was just talking about like if we're going to run this in a real environment, what would that look like? Well, we would need some like durable job execution because at the end of the day, these are all jobs that we're running, right? So we need some sort of queuing system to be able to run this. We internally use temporal. You probably need some infrastructure, probably not your laptop to do it. Although you could use your laptop. Like you generated 10,000 records, that's not that bad on your laptop. 100,000 should take a little more time, but you could do it. You want to expand to include multi-table data sets, like nobody's database is one table. So as you start to work with multiple tables and think about relationships and dependencies, you want to start thinking about that. You want some observability and evaluation built in as well, especially if you're doing the statistical characteristics side of things. You want to make sure that your data is representative of your input data. And then we want to refine our use cases, right? So like use IBAN instead of SWIFT, other card number types, and just continue to work on it a little bit longer. Oh, my computer is choking because that model's running. All right, cool. Well, hopefully in this workshop, we built a basic synthetic data generator, both in Go as well as a little bit in Python. And then we also learned some open source tools that I hope can be useful for you guys. I'd definitely recommend, like I mentioned, checking out Bento. It's great. We're really big fans of it. You can check out some other tools like I mentioned as well. And hopefully this was useful. And I think we have 5 minutes, so always happy to take any questions if we have any. Any questions, thoughts, concerns?
Question.
Yeah.
For the data that you have generated right now,
Yeah.
does it maintain the same number, or is it completely random new number that's generated? It's not randomizing the data, it's completely new. Right?
It should be completely new as long as your training data set is big enough. You can't get into like the model collapse problem where like if you only give it 100 records, it may start to reuse some of those. At the minimum, it will always reshuffle, so you have a new record, but like you don't want that data to come down. So as long as your training data set is big enough, and that depends, and you can kind of like work with that, it'll generate brand new data.
So do you recommend with the synthetic data that's generated, you recommend doing a check with the initial data because it's a payment numbers?
Exactly. I would recommend checking it. I actually had that as part of I was going to do that as part of the presentation. Yeah, I'm just going to interrupt this so I can use my computer again. Here I was going to like show like, hey, you can actually select where the card number, and this was the card number that I had in the original data set, and show that it didn't exist. But yeah, just timing. But yeah, as long as your training data set's big enough, you should be able to get completely new synthetic data.
I have a question.
Yeah.
So you mentioned like trace, they are using the synthetic data for detection.
Yep.
And could you elaborate more, like what kind of method? Because you introduced two methods, rule-based and model-based. So
Yep.
what kind of method do you think is more kind of practical in this kind of real-world use case?
Yeah, definitely. So most of those fraud detection use cases or actuarial, like underwriting use cases, typically we use a model to do it. They normally don't use rules-based. Because rules-based doesn't maintain those statistical characteristics as well, it's really hard to get that to work for like a model when you're actually using that model to like infer if somebody's, if this is fraud or not. And so in those cases, like when you care about the statistical characteristics or the structure of the data, you always want to use a model for that. Some you can use a CTGAN model for that. People are using LLMs in some ways for some of that today. LLMs are a little bit slower, of course. Like this is fairly fast. Like I don't know if you've ever gone into ChatGPT and were like, write me a mock insert statement for like some table because I need to work with it. It's just like slow and always outputs 10 records. So when you want to generate a lot of data, I think this is where like a very specific model can work. But they're generally always using machine learning models for that.
Yeah. And one more follow-up question. For CTGAN, if the column, there are lots of columns, will that impact the performance?
Yeah, more columns will definitely make it slower. I think the most columns I've ever tried it with was maybe like 20. And it takes a little bit longer, but then, you can throw more compute at it to go a little bit faster. You can let it kind of run for some time. But yeah, the more data it has to generate, the longer it takes for sure.
How about the data quality? Let's
It could. Yeah, I mean, it's, at least my experience, like 80% of any data scientist job, at least when I was building models, was like getting the data to a point where it's actually usable. And so you definitely have to spend time making sure that your training data set is clean, it's high quality, you don't have like random data quality errors, and then you actually can run the model on it. But yeah, I mean, that will definitely impact the performance as well as what it generates. Yeah. Cool. Any other questions?
If there are no more questions, I can just use your help real quick with this.
Yeah, for sure. I'll come by right after.
Like, if you got 30 seconds.
Yeah, for sure. Awesome. Well, thank you, everyone. I really appreciate it. Thanks.